What's your relationship like with the SQLite team? Are they just kind of off, especially the main guy? Is he like off on his own, like sort of not interacting with
Yes, pretty
folks?
much.
Do you have a back? Really? Yeah.
We never like we would welcome a relationship. We never went out of our way to create one. I mean, and they're very like, so we talked to a lot of people in his outer circle, but we never happened that we had the chance to chat too much.
SQLite is having a moment right now, and it seems like you and Pekka and Turso are like one of the reasons why. But between Turso and Lightstream and Aaron Francis and Kenzie Dodds and a lot of people just like advocating for SQLite.
Well, DHH and has been talking a lot about SQLite as well, right? The Primogen and others. So like I wish I could say we're one of the big reasons. I think we're more of a follower. I think what happened there is that we saw this and then we decided to move the company in that direction, right? When we spoke last, I think we were just pivoting to Turso. Our company also did not start as a database company in a much similar vein as Scylla.
How do y'all think about marketing to developers? Because I think you have done a good job about that on a few fronts. I guess, like, what have you learned in your last couple of years at Turso doing this? Hey folks, this is Alex. Today we have Glauber Costa on the show, who's the CEO and founder at Turso. They provide like this managed SQLite with some really interesting capabilities that's like changing just sort of like what application patterns you can do. So we talk about those. I love following Glauber on Twitter because he shares a lot of really good technical stuff. He worked in the kernel. He worked on high performance databases at Scylla. Now he's working at Turso and just has some interesting thoughts. He's got a great podcast too, The Save File, which is about developers and religion, which I think is really interesting. So check that out. He had some awesome thoughts on, hey, where's NoSQL at? Where are vector databases going to be, and what's that going to look like in the next couple of years? And really changed my mind on some of that stuff. So I think it's worth listening to that. If you have any comments, if you have any other guests that you want on the show, anything like that, feel free to reach out to me or to Sean. But with that, let's get to the show. Glauber, welcome to the show.
Well, thanks for having me, Alex. A pleasure to be here.
Yeah, absolutely. So you are the CEO and founder at Turso. I'm excited to talk to you. We talked 18 months ago on Software Engineering Daily, and I think you're like one of the best follows in sort of the database community, but also like the technical dev tool founder type community and things like that. But I guess for people that don't know you, maybe give us a little background on you and Turso.
I'm happy to do that. So and glad to be talking to you again. So I, as you mentioned, I am the founder and CEO of Turso. Before that, my career is actually pretty simple because I never job hop too much. Right? So I spent 10 years in the Linux kernel. Most of that time at Red Hat, not exclusively, but most of the time at Red Hat. And this is where I met my co-founder. So Pekka comes from the same background. He was the maintainer of the memory management subsystem for Linux at the time. I've done all sorts of things. I've done file systems, I've done storage, I've done virtualization, I've done containers, and we got to be great friends. I later joined as employee number 3, and he joined as employee number 4, a startup that originally was doing something called the unikernel, which might have been ahead of its time. There are a couple of companies, one in particular that I recommend called Unicraft. They're trying to do this again today. More successfully than we've done it in the past. But the product didn't quite work. And after 2 years, the company pivoted to a database called Scylla, which is in the NoSQL petabyte scale space. So Pekka and I just got catapulted into the database world. And it wasn't something that we did by design. It was just something that happened to go in that direction. And I did have a 1-year stint at Datadog. So after 7 years in my case, 8 years in his case at Scylla, I spent a year at Datadog. It was great for a variety of reasons. Datadog's a fantastic company, but it was the right time for us and the right opportunity for us to found the company. And here we are at Turso.
Yeah, absolutely. I think you told me that story that Scylla started as a unikernel company before, and I had forgotten that because I know Scylla's great. I had forgotten that they started off as unikernel, and I forgot that you were employee 3 and 4 for Pekka there. So that's super interesting. I also think it's
technically I wasn't the third, but one of the people that were there ahead of me quit quite early and was never at Scylla. So I kind of grandfathered myself in as number 3.
That counts. Yeah. And I also think it's fascinating to see like you're super technical, like, down in the kernel and doing databases, all that stuff, and then pivoting into founder CEO, which is like, you still have a technical company, but you're doing, marketing and biz dev and all that sort of thing. I think that's a fun transition there.
It is a challenge. I think it is one of the biggest challenges that I face on a personal level, right? Because you just have to go into a different. The challenge there is that, and I heard is actually one of the things that we are very blessed with at Turso is the amazing roster of investors and advisors that we have. We have as investors in our company, for example, Guillermo Rauch, the CEO of Vercel. We have Jordan Tigani, the founder of Mother Duck. We had Yoran, the founder of Tiger Beetle. All of those folks are as investors in the company. And we have one advisor in particular that very early on, he gave me this advice and it was transformative. It's like a lot of founders who are technical founders, they go into like found technical companies, but then because now you're doing something like you're not a business person, you are so you end up acting on a caricature of what you believe a business person should be, and then you just do everything wrong, right? Because say like, look, this is how business should look like. This is how this should be done. And you forget that as a developer, you will never in 1,000 years buy a product from a person that is behaving like you are now, right? So I mean, and this advice was given like very early on, not because I was doing that. On the contrary, he was saying like, just don't do that because this is the mistake that I see a lot of founders making. And man, what a great advice, because we do have this instinct. We understand that, look, this is new, this is uncharted territory, that I have to be different, I have to act differently. But you also, I mean, through this advice, I learned very successfully that you can't forget that you are, at the end of the day, representative as a developer of the product that you're selling. Then put yourself in the position of this buyer, and like if somebody comes up here with a lot of jargon, would you, as an engineer, would you buy that? No, so don't do that, right? So it's a good line for us to be walking.
Yeah, for sure. And yeah, I think marketing to developers and like also just like cracking dev Twitter is like a hard thing to do. And I think you've done a good job of that. So it's like, I think it's impressive.
Well, better
the
than
background.
Pekka.
Exactly. No, you both, both of you, like, in addition, like you're both good on Twitter, but then like also put out like some really deep technical stuff, which is like, hey, you're nerd sniping some people with some of that stuff, but then also like, I think have a pretty good and fun, just sort of a vibe on Twitter.
Appreciate the recognition here.
Yeah, for sure. So I want to talk about Turso, and it's interesting because like SQLite is having a moment right now, and it seems like you and Pekka and Turso are like one of the reasons why. But between Turso and Lightstream and Aaron Francis and Kenzie Dodds and a lot of people just like advocating for SQLite.
Well, DHH and has been talking a lot about SQLite as well, right? The Primogen and others. So like I wish I could say we're one of the big reasons. I think we're more of a follower. I think what happened there is that we saw this and then we decided to move the company in that direction, right? When we spoke last, I think we were just pivoting to Turso. Our company also did not start as a database company in a much similar vein as Scylla. The story, of course, is different in many ways. I mean, it has parallels. What our product, I think, in fact, was doing a lot better than the unikernel product. We were users of SQLite, but then we noticed, I mean, it was just palpable to us how much more people were talking about SQLite versus a couple of years ago. And then we started trying to understand why, and we're trying to understand, okay, is there, people would come to our Discord and the thing that they would ask the most, I mean, our product was not SQLite, but it would use SQLite. And the things people would ask the most were about SQLite and the use we were making of SQLite. So it became clear to us that, look, maybe this is a better direction. And we quite successfully built Turso as a result of that. So look, obviously, we always try to talk about SQLite, but I think we're riding a wave here. We're not creating this wave. This wave was already there. We just identified and trying to follow what the market people will call the secular trend, whatever that means.
Yep. Okay. So I guess walk me through the timeline. So you had your previous product, it had SQLite under the hood. And just for, I assume most folks are familiar, but SQLite, hey, it's basically a file that you just open, within your application. But you all forked it into libsql, right? Which basically enables more of like a client server model of libsql. Is that the best way to describe that?
Well, no, that was not even, that was one of the things we wanted to do with libsql, but libsql was not even that. I mean, libsql, if I was starting today, that will be, by the way, as a company builder, this distinction, even the marketing, the naming already is something that we will be better off without, because we have to talk about libsql and then we have to talk about Turso, and those are two different things. But if I was starting today, and of course knowing the future, I would have just used the same name and called everything Turso. But what happened is that we put this fork of SQLite out, and we didn't necessarily have the intention of creating a product out of this, because remember, as I said, we were seeing that the libsql essentially worked and functioned as the last drop in the bucket, because we were seeing that the things that people liked the most about what we're doing was SQLite. All of the things that people like, all of the characteristics of our product were like the fact that, wow, I just is a backend that I do an npm install and it works, and there's, and it's already working. There's nothing to set up. All of those things that people love were stemming directly from SQLite. And then but we knew the SQLite by itself didn't have all the things we needed, and we wanted SQLite to be more than it was. That's the reality, right? And there were other projects that tried to enhance SQLite. There was LiteFS, there was LiteStream, there's a lot of things like that. But all of those projects operate with the assumption that SQLite cannot be changed. And SQLite cannot be changed because it's in their website. It says we're open source, but not open contribution, right? So we're not going to be able to change this. And so you end up building around SQLite, right? And what we've done is that, look, for us, this is not going to work. For the ambition that we have for this project, for this company, this isn't going to work. For to get where we need to be, we need to fork this and be very intentional about how we change SQLite. So we forked it, and we saw a lot of interest. We saw 1,500 GitHub stars in the first week of the fork.
Oh, wow.
And that is the moment, again, on those things were in the backdrop. We noticing that a lot of the interest was because of SQLite. And then we fork SQLite, and it sees like a tremendous amount of attention. What that tells us is that, look, there is a lot of interest for SQLite, but there is even more interest for the concept of SQLite and what SQLite can do. And there is space for the market for somebody that thinks about this problem in a different way. So let's do it. And then we started adding to this fork things like replication, the client server. Other things came later, like embedded replication. We do backups to S3 natively. So there's a lot of things that we added to this fork. Some of them we don't use at Turso, but they're there, right?
Yep. I guess, like, how much active development is there on SQLite proper? Is that like something that you see, like, they're updating that all the time? Is that like kind of a steady project?
It does get updated a lot. The thing is that SQLite is a fairly small team, right? So just at the moment, our team is bigger than SQLite's. Obviously, it's an unfair comparison for a variety of reasons. One of them being the fact that we are a cloud service, so a lot of our effort goes into maintaining the cloud service, not just writing the software, but it's a fairly small team. SQLite is essentially a one-man show. There are other people who contribute as well, but the best of my knowledge, there are two other people who are recurring contributors. But that limits, of course, the amount of progress that you can make. But it still sees very active development.
Yep. And then what's your relationship like with the SQLite team? Are they just kind of off? Especially the main guy, is he like off on his own, like sort of not interacting with folks?
Pretty much.
Do you have a back? Really? Yeah.
We never like we would welcome a relationship. We never went out of our way to create one. I mean, and they're very so we talk to a lot of people in his outer circle, but we never happened that we had the chance to chat too much. But like for us, it's again, it's more on a personal level. Everything I hear about Richard Hipp is that he's a fantastic person. Obviously, a fantastic engineer. The result is there. So I think there is a lot for us to gain from that, but it's not something crucial. It's not crucial for a roadmap. In fact, we do intend for our fork to become even more aggressive in the near future. Just recently, as an example, we added so far one of the features that was the most ambitious feature in terms of like how much it diverges from SQLite, which was vector search. So if you use Turso, for example, today on device, and we have a use case that is being published on our website today about it from a company called Kin. The website is mykin.ai. They're doing essentially an AI assistant, fully private, on device, with doing vector search in a RAG model through libsql, because libsql allows you to do this, right? Again, because we just added vector search natively. And you can do this in SQLite through extensions, but extensions are limited in what we can do. The way we work is that like vectors become part of the query syntax. Like you can just create vectors and it integrates perfectly with your data, like without having to install extensions, without having to do any of that. So we want to be able more and more to make those changes. We keep hearing from people that, hey, SQLite is amazing, but the way it does schema changes is quite weird. Can you make that better? So we actually already made better in some ways. But there is a limit to what we can do without making large changes. So we have in our roadmap to make more and more aggressive changes, essentially to bring, we believe, like SQLite to its full potential, like the model of a database and a file to its full potential.
Yep. How important is it for you to like maintain upstream compatibility versus like you're saying, like, hey, if you can do some certain things better, like maybe even like schema changes in a way that breaks with upstream, like I guess, like how do you balance those considerations?
So there, we have to split that question in pieces, I think, for me to answer competently, because what does it mean to maintain compatibility, right? Just maintaining compatibility with the file format, absolutely, sure, we want to do this. And in fact, if you look at our vector search, if we look at our vector search, obviously SQLite cannot read and do vector search on the vector search that we added. But SQLite can still read that file, and those vectors will be shown as blobs, right? But so with SQLite reads, if we import the SQLite file and you add a column with blobs, again, you can do this and still the same file format. So everything is the same file format. That I think is very important to us. The way SQLite is built, though, is I believe very weird for modern standards. I mean, it has a place in history, and it does have technical advantages. But SQLite, if you look, it is a directory full of C files, and then the process of compiling SQLite actually does not generate a binary; it generates a C file. So what you do is that you get all of those. They call this the amalgamation. You get all of those C files and you compile that into this one big C file that you can now insert into the build system of whatever tool you have. And this is a very interesting way of consuming software that, I mean, makes sense for SQLite. Allows, for example, for you to maintain compatibility with every single kind of system out there. But maintaining this build system, for example, for us is not important, right? Now, maintaining compatibility with the language, it's important to support the things the SQLite does, but we want to add more, right? So it depends on what exactly we're talking about.
Yep. And if I remember correctly from last time, are you, like, most of the new features that y'all are doing in libsql are written in Rust? Is that still the case?
Vector wasn't, right? So for example, there are some features, and we're still seeing like what is the best way to solve this problem. I want to give just a preview here. I don't know if you want to add the link later, but my co-founder Pekka has a personal project that called Limbo, and the reason it's called Limbo, it's like the state of confusion. So like don't read too much into that yet. But Limbo is essentially a from scratch rewrite of SQLite compatible within those constraints that I just told you, fully in Rust. Because, for example, what we always try to do is add those features to the extent possible in Rust, and then you add a couple of hooks into the C library that are just calling into a Rust code. For vector search, it was so invasive, this just wasn't possible. And some of our users, we have a couple of users and design partners, they're starting to ask for things that are quite complex. And it led us into us experimenting. This is very experimental. It's not a direction that we committed to yet. We are experimenting with the idea of, hey, look, I mean, SQLite is actually not that big, which is why for us the idea of the fork was good to begin with. What if we just rewrite it? What if we use like a modern architecture? What if we do full Rust? And the beautiful thing is that this is actually the first time, Alex, the first time that I'm talking about Limbo. This name is going to change if it becomes an official Turso project, but it may not. But I'm moving into the direction of making it into an official Turso project because without this is the first time I'm talking about it in public on a podcast. And Pekka tweeted about it a couple of times, and that's it. And if you go to the GitHub repository in which that is being hosted, it has over 20 contributors doing very deep contributions. One of them we actually hired to work on Turso. If anything, if nothing else, it already worked to help us find this fantastic person. But it has almost 1,000 GitHub stars and over 20 contributors without us never having talked about it, right? So I think there's a lot of there is a future, possible future that is growing in likelihood that this code just becomes like libsql. And libsql is something that started as a fork but ended as a rewrite. I love the analogy of the ship of Theseus. Pekka doesn't read because he's not very smart, so that's how it works. So he did not know who Theseus was, so we went we couldn't adopt the name. Just
yeah. Oh man, that's super interesting, and it'll be interesting to see like what happens even just like category or description wise with Turso in if sort of SQLite and Limbo start to diverge a little bit. And it's like they're mostly compatible for a while, but now it's like when does that just become enough of a different thing? That's pretty wild.
Well, we this happens to us in the past. Our previous company, Scylla, started as a fork, as a rewrite of Cassandra that was fully compatible, and over time it diverged. And you want to maintain compatibility with things that are coming from that database, but like Scylla added many things that were not present in Cassandra, right? I remember that Cassandra has this big YAML file, and Scylla would still read the YAML configuration file, but it would just ignore a lot of options because it just didn't make sense. Scylla, as an example, had a lot of intelligence to automatically tune the database to your workload, and Cassandra has a lot of those parameters for the size of the heap and the size of this and the size of that a user had to tune. Scylla would ingest the file, but ignore that. So, and then it started like some of the features were being asked by some of our users that Cassandra just didn't implement. So we implemented first, and they never did. So, yes, it does diverge, but even today, for example, I suspect a user that is using Cassandra can just go and migrate to Scylla, and this is something that binds you forever when you embark on a journey to either fork or rewrite or do things like that. And I think our story with SQLite will always be similar. Like I think I always want people to be able to get a SQLite file and ingest it in Turso, and I want people to be able to export a Turso database as a SQLite file. I think this has always going to be the case. Once more, if you are using something that SQLite doesn't have, so that there are limits to what that can of how that happens, it gets shown as a blob or the column is disabled or then you have to go into the specifics depending on what's being done. But that level of compatibility has to be always there.
Yep, absolutely. Cool. Okay, so I want to talk even just like patterns you're seeing with Turso, because I see like a lot of like interesting patterns. I mean, some are just like straightforward application patterns, but now you can use SQLite, and some are like, hey, new patterns that you can't do with other databases. So just in terms of like what you're seeing with folks, I guess, one of the original downsides of SQLite is hey, if you have multiple compute instances or something that need to access it, it's going to be tough because it's usually going to be on a local machine. But now you have the client server model. How many like how many of your customers are using it that way as just sort of like a replacement for MySQL or Postgres, but even still have a similar, 3-tier architecture or something like that?
In terms of numbers, so if I go look in terms of number of users, this is the most common use case. We have a very generous free tier, so people show up. We have a hobby plan that costs $9 a month, and in fact, by the end of the year, again, another announcement here. By the end of the year, we have all the intention. We'll see if we can make it happen, but we actually want to reduce that price even further. And so if you go look at that cohort of users, I think a lot of them are using this as really just a SQL database. And it could be MySQL, it could be Postgres, it could be whatever, but it turns out it's SQLite. So the advantages there is that it's super simple. You can still do the local testing, right? You still retain that. You can commit the SQLite file to your Git repository. Whether or not you actually should do this is up to you. But but you have this thing that works locally, that you develop locally, that you commit locally. And helps you in your CI tremendously. But then, as you said, it has those disadvantages that I cannot access over the network. And then Turso fixes those disadvantages because Turso is accessible over HTTP. That's always the case. So you can send an HTTP request, the request comes back, and there you go. And then this is backed up by the Turso service. So you have your backups. You can restore to any point in time in the past. The more you pay us, the more retention you have. So that's a difference in the plans. But even for the free plan, you can always roll back to any instant in time in the last day. So you have that, and you can have many API services connecting to the same database because you're connecting over HTTP. So there's no disadvantage. So there's a lot of users using that, right? Just in terms of numbers, this is the most common use case of Turso. In terms of revenue, that's not the most valuable use case of Turso. That will be a different one.
Okay, sounds good. So let me talk about, as I was sort of looking at your site and have just like seen your marketing over the while, the second one I think of is like embedded replicas, which is, I have a central sort of SQLite somewhere, but then, maybe each my user's mobile device is replicating some subset of that data likely onto their machine, or maybe I just have different instances around in different places that has like a specific customer's data or something like that. So tell me about embedded replicas and what you're seeing, what that enables there.
So embedded replicas, first of all, it was a great description. Congrats. I think it shows that, at least our message getting across. There was only one thing incorrect with what you said, is that it's not even fully incorrect, that we replicate a subset of data. The embedded replica is a full copy of a database. And it is, but the reason this is actually not even completely incorrect is that another pattern that we see a lot in Turso, and it is in fact the pattern that we see the most value being derived from Turso, is multi-tenancy, right? So Turso allows you to create 10,000 databases on the Scalar plan, unlimited databases on the Pro plan. So you can just create as many SQLite databases as your heart desire. And that means that you can create, just segregate the data that you have in multiple databases. And if you think of your data set as the collection of those databases, then yes, like you can have a per user database, and then you replicate the data for that particular user to their mobile device. So from that vantage point, you are replicating a part of the data. But from the point of view of a database, we replicate the entire database.
Gotcha.
Mobile device is one of the use cases. The other use case is just like, if you do this, for example, you no longer need a Redis cache or anything like that, because now you can have a database, a copy of the database inside the server that you're accessing, right? And you can have microsecond level reads into that database. So we see a good mixture of both. I just mentioned in the beginning of the episode this use case that we're publishing today with Kin. And their use case will be more of a mobile SDK. In fact, today we are announcing we had conceptually the idea that you could replicate your mobile device, and some very stubborn people doing this. But one of the things that we're announcing today in our launch week is the mobile SDK. So as you see there, we're announcing a iOS native client, a Android native client, and community contributed React Native and Flutter. So you can build mobile applications like that with SQLite as just a file if you want. That's fine. Or with the Turso sync engine, right? So you can have a replica of the data in your mobile device.
Gotcha. And so just so I understand, most people are combining that sort of like database per tenant feature with embedded replicas. So they're just replicating their customer, like that specific customer data down? Or do you see people that, hey, maybe it's a smaller database that they need to get and they'll just replicate the whole thing for sort of everything? What patterns are you seeing?
I don't know if it's most people. It's certainly not most people, because as I said, the majority of users use Turso in a very simple way. The high profile use cases tend to mixture those things in one way or another.
Yep. I know. Okay, so the database per tenant one is like super interesting. I remember being like really excited about that when that came out, and then I saw a few folks like Dax, I would say like, hey, one thing that's tricky about this is if you have 10,000 databases, what happens if you have a schema change or want to do some analytics? As I see, like y'all have some stuff for that. I guess what's your answer to that? How much did you have to build or support around those use cases?
Definitely an account to follow. Definitely a person to pay attention to. But I don't think this is the full picture in this case, right? And when somebody smart doesn't see the full picture, usually what that means is that you're missing context on the use cases. So I'm happy to give that context. The most interesting cases we have, and this is not an issue at all. And the reason for that is that in the most interesting cases that we see of multi-tenancy, my user's user is the one driving the schema and not my user. So let me give you a couple of examples of places where Turso is doing super well. Turso is doing super well with AI application builder. So in fact, it's clear that Turso is becoming like the database of choice for AI builders, right? And why is that? If you're building an application, and this is just an example, of course, of what you can build with AI. If you're building an application where, in fact, let me refer to a use case that we published yesterday on our blog on Monday. So on Monday, we published this use case with a company called Adaptive Computing. And Adaptive Computing is essentially allowing you to generate a full application from a prompt. So the website is ac1.ai. You can prompt something and say, hey, give me an application that does this. And they're not targeting technical people. They're targeting like people like my wife, who's a baker and wants to build like an application for bakers. She doesn't code. So she might want to prompt the entire application. And look, every single one of those applications is completely different. They don't have the same schema. They don't need to have the same schema. But then, like as the user prompts, they to be a full stack of a fully functional application, they need a database, and Turso is just providing those databases. And the reason Turso works fantastically with that is that those databases, by being a file-based database that is fully serverless, doesn't have cold starts and all of that. Look, you're not going to beat the cost of this. Like even the databases that are just doing scale to zero, it's hard to compete with for databases that get used sometimes with this idea of like, hey, this is a file. If you query, I serve your file. If you don't query, it costs nothing, right? So we're going more and more in the direction of massive multi-tenancy with the Turso platform. You have those and look, other example, you want Claude or Devin or any of the Terminator prototypes out there to be generating a code for you, and you're going to execute that code automatically in your shared database. Good luck with that. No way, right? No way you're going to get Devin direct access to your production database. But in Turso, like you have all of those databases, you have a bunch of databases. The databases are completely split. The schema might be defined again by the application. So you let the application do, like you let the sub application do whatever they want. Note that I'm not saying that Dex is wrong. I'm just saying that he misses the context from that.
No, yeah.
He is right.
The thing I would say is like, this is like such like a new use case. Like I would have just never thought even how to do this in just like Postgres or MySQL or something like that. So then the fact that this is possible, like it's possible, people are using it for things that you just like wouldn't have imagined before, you know, in some ways. So
yeah, like we have people creating like databases by the second on Turso, right? So just hey, something happens, like an event happens here. Here's a SQLite file to back up the database, and a lot of the application code that is connecting to the database again is automatically generated application code that need. It's a problem very similar to big data. Like and I remember we talked a lot about it when I was at Scylla. The issue with big data is that the unit of data, like the megabyte of data in big data, is worth nothing. The data is only valid because you have a lot of it. And now this is how big data works. Like each piece of like example of something that people do with big data, like session tracking on websites, right? The fact that the user clicked the button doesn't mean anything. I mean, that information has no value. If you lose it, nobody will notice. But the fact that you have 1 million users and 70% of them click on that button, like that starts to have value. And the use case here is very similar. Each of those databases, we've been calling them more and more like ephemeral databases. Like each of those databases that people create on Turso, they're not worth a lot. They're disposable. They're ephemeral. They're going to go to the trash. Most users will never go back to them. But the fact that you can now have 1 million of them, that's worth something. So that is a use case that we're seeing a lot. Now, again, as I said, DEX is not wrong. And for SaaS applications that want still like I have a shared schema and I want to just segregate the data per user, either because it's simple at the query side or because I want to encrypt this data with different keys and I'm doing like some medical thing or financial data. That happens, and what we try to do for those use cases is build the tooling to make this problem less of a problem, right? I think this is always going to be a part of the trade-off. A part of the trade-off is like, yeah, now that you split your data into multiple databases, you have this trade-off to make. But we have, for example, schema databases. When you have a schema database, you can connect child databases to the schema database. Then you change the schema of the schema database, and that is pushed down to all of the child databases of that schema database. That's one way. Now, analytics, we honestly, at the moment, don't have a great solution for. We recommend users to just write twice, which again is a fairly common pattern, actually, and have a separate database where you do your analytics. This database might not even be Turso. In fact, DuckDB is a much better database for analytics. So if you want to keep everything local and trendy, like you can have your data duplicated in both Turso and DuckDB, and then you do your analytics on DuckDB.
Yep, gotcha. You mentioned like sort of automatic or like incremental updates to S3. You mentioned something with libsql earlier of backups or something like that to S3. Is there a way to like either get change data capture or those snapshots so that I can feed those into my analytics systems very easily, or what does that look like?
We have some form of change data capture in Turso. It needs more work, I think, until we can stamp it as a feature that we're behind. But we have a change data capture feature.
Yep. Okay, cool. Last sort of like use case I want to ask about that I see about and especially saw a while ago is just like, hey, this edge database idea, right? Where I have my database somewhere, or I have users in US East 1, but I also have them in Brazil and in Toronto and Singapore and all these different places. So I replicate them out that way. Is that still something you're seeing a lot of? I guess like where do you sort of stand on that use case?
Yeah, we see that a lot. In fact, we don't talk too much about it these days because I think the concept of edge became very confusing for a variety of ways.
It really did. Yeah.
If you go look at the definition again, what we do with embedded replicas is edge, right? Because we're pushing the data all to the mobile device and you have those copies of the database that you control. So this is a form of edge, but especially in the JavaScript community, people came to understand edge in a different way, tied to specific JavaScript runtimes. So we toned down on the message of edge a little bit. What you're describing, this is something that today on our platform we call global replication. And global replication is something that we still do. And again, the advantage there is this, that you can have SQLite being so cheap and so easy to operate, those replicas become quite affordable. So you can have those replicas across the globe, and we provide them in our infrastructure. But honestly, we see less and less people using this because in many situations, like if you're using a platform like Cloudflare or Vercel that are serverless platforms, you need something like this. But for the people running this on servers, they actually get more benefit by replicating the data inside their server, right? Which is the last mile instead of almost the last mile. So as we announced embedded replicas, and as we saw more people using this in platforms that are not serverless, I actually think this is becoming little by little the preferred way in which people do replication with Turso. But we still have global replication, and that's still a use case that we see a lot.
Gotcha. Okay, you mentioned earlier that like on the scalar plan, you can do like 10,000 databases or something, and then unlimited on higher plans. I guess what are the axes you charge on in terms of like 10,000 databases for $9 a month or whatever? Sounds wild. I guess what is costly for you? Is it must not be the actual database instances themselves, it's the replication. I guess what do you sort of cost on?
Yeah, so a lot of people, first of all, the cost doesn't matter, right? Because at the end of the day, you need to have a package that people want to buy. And a mistake that I think a lot of people make is think from the costs up and think, oh, this cost me this much, therefore I have to put a markup of 20%. Like this is not how any business should work. But understanding the cost is obviously important, right? So not neither here nor there. The answer is in the middle. But some people think that, for example, a database costs us nothing because it's just a file, and that is also not true. Because you have, for example, to have independent backups for those databases and different, it's all the same bucket, but different directories within your S3 buckets, and you need to manage those things. So there is a cost for us to get a database, but this cost is low enough so that when you're talking about the Pro plan, for example, that costs $500 a month and is targeted towards people doing those things in production, we can just say, look, that maybe if you create 1 billion databases, we're going to have issues, but that's fine, right? Just if you're creating 1 billion databases, you're probably using the platform a lot in other metrics as well, and it will work out. But for people you can create 1 million databases, and that cost is still not a cost that will bug us too much. Again, given the fact that you're already paying a premium by being a subscriber of our Pro plan. Then you have storage, and the thing that costs the most is the compute, and that's true across every database, compute and memory, which is why our model works so well, because I can respond to that one single request and only account for whatever you use for the one single request, and by the way, in our platform, we don't talk about compute and memory. We talk about rows that you touch, which is something very easy for a user to understand. It's rows that you've written, it's rows that you've read. Reads are way cheaper than writes, reflecting the fact that SQLite is a database that reads a lot better, reflecting the fact that for every write, if you want to do point in time restore, you have to keep those copies and do all of that. So those are priced accordingly in a way that reads are cheaper. You touch a row in SQLite, you pay for it. You don't touch it, you don't pay for it, and there you go.
Yep. Very cool. Okay. I want to, since you're not only working for a database provider, but you worked in the database space for a while. I want to talk about just the market right now and what you're seeing out there. I guess I want to start off with vector search, because y'all added that to SQLite. How hard was that to add? How different is that from sort of the traditional things that databases do? And yeah,
it wasn't very hard, which again, my view, for example, taking a step back, I'm obviously biased with that, but I'm not a big believer in NoSQL anymore. I think that is one of the reasons I left Scylla and started my own journey. And it's not that NoSQL doesn't matter. If you are selling a NoSQL database, it will obviously respond to me but my revenue grew this much at this quarter and etc., which is probably true. But what happened is that 10 years ago, everybody was looking at NoSQL. Whatever the equivalent of early 2010 DAX would be looking at NoSQL. In fact, I think DAX was working with NoSQL. I discussed this with him the other day in 2010. So everybody was looking at NoSQL, and there were reasons for that. And a lot of people who are cynical think the reason is just hype. It's never just hype. If it's just hype, it doesn't go as far. I mean, NoSQL went pretty far, but there were reasons that led people to look into NoSQL. And as a quick summary, I think the reasons were just that hardware just wasn't powerful enough, right? You had to scale out. Like every single mom and pop shop website, if you wanted to have any resemblance of, unless you were doing something just for like your local church or club or chess club or etc., anything that sells anything online would need some form of scale out. So you would reach out for NoSQL, and that is not the case anymore, right? It just you can do a couple of terabytes of data on SQLite, and that's fine. I mean, just that's part. I think it's part of the reason why you're seeing this resurgence of SQLite. Which doesn't mean that they're not use cases. They're so huge that for which a NoSQL database is so much more specialized that you see like large advantages of using that. So I think it becomes a fringe. I view vector search the same way. The other day, one database, by the way, that I love in the vector space is called TurboPuffer. I don't know if you had the chance to meet Simon.
Is that like the S3 based one?
S3 based and etc. Like they have this beautiful, beautiful architecture. Again, the engineer in me just reads that and smiles. It's a beautiful architecture. It makes perfect sense. Simon is a unreasonably smart person, and I'm seeing that they're succeeding, and it's great, and the demand is clearly there. But I think it's going to be similar to what we saw with NoSQL. Most people using vector search for like any kind of application that you're building are probably better off without a vector database. If vector search was incredibly hard to implement, then vector databases will be justified. Vector search is not very hard to implement. Again, we added most of our problems were how to make this work with this very unique and ancient SQLite code base in C, right? It was not like how to implement vector search per se. So it's the commodity issue. It becomes a commodity. Every single database out there these days has vector search. Like having vector search is no longer something that you can differentiate on. But I believe there will still be those use cases that for which you have so many vectors and you have such precise and interesting requirements that a vector search database is justified.
Yep. Oh man, okay, you totally sniped me because I was also going to ask about the future of NoSQL, given your work on Scylla, and because I've been seeing sort of the same things, like hardware's just getting so big. There's also just a bunch of distributed SQL options. Yeah, that's interesting. I do want to talk about the vector store. Like, I think you're probably right, and it's not super hard to implement. But what about just the sense that it requires, almost like full text search, it requires a different set of resource requirements than your traditional OLTP. You don't think so?
It's so like. Vector search is way easier than text search. In fact, it's so, and it's just not that hard. And there's nothing like the way we implement vector search in libSQL. It's a column where you add the vector. So you can have here's how it works. You can have your SQL columns, right? And then it's a text, is an integer or whatever, or is a vector. That's it, right? And what does vector search means? It means that you are given a vector. What is a vector? Is something that one of those AI models generated. So the model generates a vector. So here's an example. You have a database of movie synopsis, right? So for every movie synopsis, you get the synopsis, gives it to OpenAI or Claude or whatever, and Claude will or the model will spit a vector back to you. So you will store in your database this and this, like this is the metadata, this is the name of the movie, this is the etc., and this is the vector. And then you're going to do this for every single synopsis. Then a user types on a prompt something like, "Hey, give me a movie that has like a Scarlett Johansson and she's flying." Whatever ridiculous example you can come up with, that generates a vector. Now, what you're going to do is that the brute force method is that you're going to go over every single one of those vectors, and using a mathematical function, which is very easy to implement as well, like you do it in a couple of hours, using this mathematical function, you will see which vector is the most similar to the one that you gave. And then you say, okay, so now this is all the metadata that I know about that movie, and now you found the movie and everybody's happy. Now, this is slow because you're doing a brute force search, but look, what do I mean by slow? You can do like maybe 100,000 of those searches with brute force in 200, 300 milliseconds on LibSQL, right? So that already covers like so many of the AI applications that we're going to see. But sure, it is slow. So what you do every time you want to, what do you do, Alex, if you have a column that is not your primary key and you want to search for that column? You create an index, right? So there is an index that has more or less this space distribution of those vectors, and that index just gives you that in a faster way. So that's it. That's vector search. I mean, there's nothing magical there.
But like, aren't those? I mean, both like the embeddings themselves. I feel like in some cases they're going to be bigger than the rest of the row altogether. You know, if you're talking about like a 2,000 dimension vector, that's going to be like fairly large. And then also just indexing. There are indexing methods, but they're not quite as like, I would say, just like naturally suited to things as like a B tree is for other, so.
Oh yeah, sure. The index is a specialized index, but again, it's not a very hard problem, right? Yeah.
And it's like a memory intensive, isn't it? But isn't it like a resource intensive one? So I guess my thesis, and again, I'm further from it than you are, was just that it's more like full text search, just in terms of the resource requirements of like, hey, it's harder than just a straight up B tree, But you don't think it's that? It's like actually,
it is harder. It might be. So I want to add a comment to what you said. So yes, those columns can be big. Turns out there is a theoretical result that is fantastic, and the Nobel Prize in Physics was recently awarded to people in computer science, which is amazing. And I wish we would understand, at some point we will, better why it is that way. But there's a theoretical result that's super interesting, that like you have those vectors with like 700 dimensions, right? So 700, what is a vector? It's just a bunch of floats. Every float is something like 4 bytes. So yeah, I mean, again, it's not gigantic. The vectors are not megabytes, but they are decently sized. The interesting result is that if you replace those 4 bytes with a single bit, it works decently well.
Interesting. Okay.
So all you need, and we actually announced yesterday the GA of our vector search that has been beta so far. And one of the features that made it into the GA that wasn't present before is this. It's called 1-bit quantization. So 1-bit quantization is amazing. It is a mind-blowing result that essentially tells you that at the end of the day, all you need is a bit, and the result, if you're storing your vectors as a bit, is decent. But if the model is aware of the fact that you're going to store it as a 1-bit quantity, it gets even better. And what does that mean for the database to support 1-bit quantization? It means that the function that you use to look for the similarity is not the same function that you would use to look for similarity. So it's a different mathematical function that you use to scan and match for similarity. The model, it's best if you use a model that is aware of 1-bit quantization. But if you are using 1-bit quantization, this is actually a super tiny column to begin with. So it's just it's not the end of the world. Yeah.
Okay, that's really good to know, because I feel like I've been trying to like figure that out, and I hear people talk about quantization, and I'm just like, well, how do you do it? How do you like actually shrink those in like an accurate way? And also like how much do you lose from it?
Yeah, quantization is like go over your vectors. If it's positive, 1. If it's 0 or negative, 0. That's it. Boom.
It's like that simple. Okay.
That's simple.
Yep.
Yeah.
And you lose something, but you don't lose that much. Is sort of like what you're saying here.
And if the model is aware, you lose even less, right? Again, and more importantly, the brute force scan takes you quite far, right? You need to get to a couple of millions of rows before, like, our index is, until that point, the indexing is actually slower than brute force, right? Especially for small vectors, like on the 1B quantized vector and things like that. So look, again, I'm not saying that those databases are not useful, because again, same as big data. Can you store a petabyte of data on SQLite? You can, but on Postgres, you may be able to. I mean, Postgres is pretty powerful, but would I recommend you to store a petabyte of data on Postgres? You're not going to even find a petabyte device to store the data on. So like, go use Scylla, right? Vector search will be a similar thing, at those very, very large use cases, or use cases with very strict requirements of how much you need to take to search for a vector. Like when things are really strict or big or both, a vector database probably is better. But it's the same situation as NoSQL, in which, but the difference is that NoSQL had its time in the sun where everybody was reaching for NoSQL, and I think vector search will not. And the reason for that is just because it's a lot simpler to implement than a time series for the database, right? The time series are very, very hard to implement. Vector isn't really.
Interesting. Okay. And then, so you mentioned the, LLM models that are aware of that you're doing this quantization. Do you have recommendations on ones that do that? Because I feel like I even searched for that and I had trouble finding ones that would receive.
Yeah, no. If you look at the blog post that we published on Monday for our launch week yesterday, you will see that we're referring to a model called Mixed Bread. Those are partners that we have, that we've been working with them for a while, and they generate models that are one bit aware. And again, the recall, the recall is pretty good. And the recall in vector search is essentially like, look, if you do a brute force search, you will find the most precise vector that matches your vector. If you the indexing is not like a B tree. This is a difference. Like vector indexing is approximate. So the algorithm is called ANN, which is approximate nearest neighbors. So you will not necessarily find the best vector, right? So the higher the recall, the higher the chances are that you will find the best vector. So if you have an index with a recall at 90% of the time, it does find the best vector. And if not, it finds a vector that is within a boundary of the best vector. So this is the metric that people are usually looking for when talking about, which is another thing. I mean, for a lot of use cases, you don't need a very high recall, right? Just if you have 95% recall, that's okay. So vector databases may be better. They likely are better to get you to the last mile of recall. But as I said, the algorithms are all the same. They don't have like proprietary algorithms to do this indexing. Not very hard to implement. So,
yeah. I'd be curious about the recall on a brute forced 1-bit quantized model as compared to like the full, 4-byte one. Like what, like if I'm, hey, I get a brute force it and I get to actually look at every one because it's actually very, very small, but I've quantized it down to 1 bit. Am I still getting like really high recall? Like that'd be a cool comparison to look at there.
Yeah. Yes. And I think the reason for that is that again, now I'm going to go on a tangent here. I'm not a specialist in the math of all of this, but the impression I have is that the space of vectors is so sparse, right? And I think this is why 1-bit quantization works, is that the space is so sparse that you don't have a lot of vectors. Think about it. If you had a lot of vectors clustered together in the same point, you would not be able to do 1-bit quantization and with the accuracy that we do. So what that that was my intuition, is that, yeah, if you do one big quantization and if you do a brute force, you're going to get pretty awesome results, especially if your model is aware of that, because probably what the model that is aware of that is doing mathematically is making the space even sparser, right? And making sure that the classification lines are sharper. So again, not the words of a mathematician here, but
no, that's probably right. Because when I think of like how they do that nearest neighbor stuff, I just think of like a 2-dimension thing and try to do like lat long. And I'm like, well, if all of them are in New York City and you like quantize those, you're going to like blur it a lot. But really, it's like, hey, if we're talking 700 dimensions, it's like you're way out in space, way somewhere else. It's like you're not even in the same universe as some of these other points. Okay.
And some of those models have thousands of dimensions. I think the biggest dimension that we support is 16,000, right? So it's supported. But most of because remember, the machine learning is older than the current version of like generative AIs and LLMs. So, but the models that LLMs use, which is what everybody's using today, they generate around less than 1,000 dimensions, if I recall correctly. But you can have vectors with like much more than that, like with tens of thousands. And at that point, I think the space is just so sparse that's why those things work.
Yep. Okay. Wow. This is, I feel like I've been like asking and reading around about this for a long time. And this is by far the most convincing argument I've heard that like, hey, this is really going to be within just like general purpose databases rather than specialized stuff. So thank you for that.
Oh, my pleasure.
I think on this note, like this is a, the blog post that y'all had yesterday about the vector search and some of those details around that is like super effective, I think, for like reaching developers and just talk about, I guess, like, how do y'all think about marketing to developers? Because I think you have done a good job about that on a few fronts. I guess, like, what have you learned in your last couple of years at Turso doing this?
Yeah, I want to call out this person by name, as I said, which is one of our advisors, Adam Frankel, probably one of the best startup advisors for developer-focused startups. And honestly, like as I said, the lesson he gave us is just do what just be yourself. And two things that he told us, and those things may appear that we don't know what we're doing, but we're actually doing those things by design, because this is coming from advice that we trust a lot, and it turns out that it worked. One of them we went through, but for the people who tune in now and didn't get the beginning of the episode, is like, look, a lot of founders, they are aware of the fact that they don't know business. They are aware of the fact that you're new to being a CEO, you're new to managing a company, you're new to the process of sales. So you start talking into fluffy marketing, you start talking into a language that you as a developer would never buy from, but you forget this because you go into this. So just don't forget it and understand that, like, just be yourself. And the other thing that Adam told us, and I think this again was transformational for Turso, as simple as it is, and I view as a corollary of this, which is developers don't like to follow corporate accounts. Ask yourself how many corporate accounts on X or whichever social network you're very excited to follow. Zero or close to zero, right?
Yeah. It's like super base, maybe if you like memes, but mostly not.
They're super good. They're good at that. I mean, I'll grant you, like, super base is super. They're the king of memes, and it works. Like it's great. Again, it does work. And then you have like those McDonald's, Burger King accounts. They're fighting each other as well sometimes, which is fun. It's great. It's okay, but like you're not looking forward to that, right? And the reason for that is that it's hard for developers to trust a corporate account. The assumption is that the corporate account is lying, because likely it is. So what you do is they said, like, just be yourself, and you go and you talk about the product. And what happens naturally, I mean, and this is not something, what happens naturally, and I think the reason that this works is that, and I have my Twitter account for a long time. I'm not making an effort now to be more popular or less popular. It's just that I use it more because I talk about Turso more, but the proportion in which I talk about other stuff is about the same. And so, I mean, it's my account. I talk about a bunch of stuff. I talk about controversial stuff. As you know, I recently started a podcast about religion. I was an atheist for 20 plus years. I no longer see the world this way. And I posted about it, got like 100,000 views and on that tweet, right? This is me. This is not a facade. This is not like, and because it's my personal face, there, even a liar, there are limits, I guess, to, unless you're Sam Bankman-Fried or something like that, but there are limits to which a non-psychopath person will go. So a developer knows that this is true. And then when I talk about Turso, like if I am saying something false, if I am saying something like this reflects on me personally, right? So I'm honest about it. And honesty is really what developers are looking for. Like I talk about Turso, I will highlight the good things about Turso. But when Turso has an issue, look, we'll acknowledge and we'll talk about it openly because it's me on the line. So I think this is what's been working super well for us. Pekka is on Twitter all the time as well. He usually has threads that are very successful in which he's talking about general concepts about latency and he's talking about like things that people want to follow. I am more personal than Pekka. Like Pekka's presence on Twitter has always been focused on like technical subjects. I do a little bit of that as well. But again, I joke on Twitter. I'm funnier than Pekka just because he's Finn. So, he doesn't have those like emotions and things like that we do. I'm joking all the time. He's talking about those technical things, but every now and then, like Turso is naturally inserted on those conversations. And I think people just like that. Get this as free advice that I got for a lot. You're getting this for free.
Yeah, for sure. I would say like be technical. Like you're just going to nerd snipe a lot of people. Like if you're marketing to devs, I think they like that, and be a real person. Like I think that's all great. You mentioned your podcast, The Save File, which I love. I think it's really good. I just listened to the episode with Josh Siri and like Aaron Francis talking about Hannah and there were some really good episodes. Strongly recommend that. I guess like what have you learned from hosting that podcast?
Well, what have I learned? I learned a lot about people that I knew, about a side of them that I just did not know, which was so a lot of those people, like a lot of those people, I just did not know because where they stand in that line of like whether you're not a religious person or not. And the reason I did not know is that it's just not something that matters for our profession, so you don't ask. But like life is more than that. Like you want to have a personal connection with people. So I appreciate having that connection. Like this episode with Aaron was the one that's done the best to me, where he's talking about losing his daughter. And like, it's such a, developing this connection with people that I truly, truly appreciate and like and respect. For me has been the highlight of that. It's super hard to run, as you know, right? It's super hard to run the show like that and the logistics. And I have a company to run. So it's not, unfortunately, it's not something that I can devote a lot of time to. I've been slowing down the episodes because, just there's a lot more Turso things for me to do. But I'm not going to say I learned how hard it is because I had already been warned by people that it's just super hard to run. But
it's a lot of work. Yeah. Yeah. Very cool. Well, I love the stories. I have one personal question to ask you. In the most recent episode, you said that you lived in Moscow for 5 years. And I know
I did.
Did you grow up in Brazil? Is that right?
I grew up. I moved around, man.
I guess tell me how you got to these. Was it like just like personal preference? I want to go check out these places. Was it job? I guess how did you get to these different places?
Well, again, I was born in Brazil by birth. So that was just I'm not I shared this before, so I'm just going to share it again. I had a lot of trauma from that. I'm just not a person that connects with that culture a lot. So my childhood and my teenagers were very, 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 very rough, and I never really had a true sense of belonging. So I moved to Moscow essentially because I had a job offer, but I had a job offer because I was looking for ways to move to just somewhere else. And Moscow was just where I got this opportunity. I mean, I was like, look, I want to go anywhere. Like I just get out of here. So I got this opportunity. I wanted that wasn't my first choice, but like I got an opportunity there, so I got a job offer and moved. It was great in a lot of ways. I lived there for 5 years, and then when the war started in 2014, I decided to leave. I did not want to go back to my home country for the same reason that that led me to leave. So I just, at that time, I lived for around 6 months as a digital nomad, like going from place to place. So we actually spent quite a large amount of time in Paris because my wife used this time to become a pastry chef. So she's been to the Cordon Bleu in France. I gained a lot of weight at the time, and we spent some time in South America, in Colombia, in Chile. I became a permanent resident of Panama. So I lived in, and I applied. I was trying to get a visa to go to the US, but at the same time applying for permanent residency, the equivalent of the green card in Canada. I expected this process to take a long time. So I was actually setting up shop in Panama. I was going to be in Panama as, that was what I was intending to be for like a year or so. But we got lucky, and the Canadian permanent residency for us was processed in 5 months, which is insane. I mean, those things, I know people for whom it took years. So we came here, and I initially to Toronto in 2020. I moved to a small town called London, which is where I am right now.
Okay. Sounds good. Yeah, that's a cool story. I heard you say that in Moscow. I was like, man, I wonder how he sort of went all these different places.
Yeah. Oh, it was great. I mean, you have to understand that I was there as I was never there with the intention of like immigrating to Russia forever. If I had that intention, I would probably, I don't know, just go hack some NSA servers, because that's one way to immigrate to Moscow, right? But so a lot of things are very different when you're in a place temporarily versus permanently. So
Yep. Very cool. Well, Glauber, thanks for coming on. Again, I love following you on Twitter. I think you're a great follow. I've learned a lot, and you're quite funny. Congrats on the launch week. Vector search yesterday, mobile SDK today. Got a couple other things coming up in the week. If other people want to find out more about you, more about Turso, where should they go?
I'm on Twitter, X, however you call it, at GLCST, as comes from Glauber Costa. So GL, two first letters of Glauber, CST, the consonants in Costa. And you can find Turso at turso.ai or turso.tech. So just the turso.ai is easier, shorter, and sweeter. So just go get us, go follow us. We also have a Turso account, Turso database, a Discord channel, which is tour.so/Discord. That's the short link. So, our community is almost 5,000 members strong now, with a lot of traffic, and always happy to chat with anybody.
Cool. Thanks for coming on. Best of luck to you and Turso going forward.
Thanks so much for having me, Alex.